Welcome to this video lesson on how to make New York pizza dough. We're going to talk about the theory, we're going to talk about the practice, we're going to talk about how to make you a world-class pizza maker. It all starts with the dough. So let's jump in here. There we go. We're going to talk about the importance of the dough in pizza making. We're going to talk about levers and outcomes, and we're going to talk about the dough making process in particular at Righteous Slice. You're going to love it. Let's start with how important the dough is. Okay, so this is coming from me to you. There really is no more important component in a pizza than the dough. All right, the dough is the heart and soul of the pizza. It's what makes our pizza righteous. And so it requires skill and thoughtfulness and attention to detail to get it right. The dough is a living organism, right? It's got the yeast in there, it's active, it has a life cycle that has to be managed. So it's not just something that you can do once and forget about. Every day the dough is different. Every day it requires someone like you paying attention, doing your best, and getting in tune with the dough so that you can make a perfect pizza every time, even when conditions are different. So let's talk about the levers and the outcomes of dough. I always begin with the end in mind. And the dough, if you look at this picture, it's light and fluffy on the inside and slightly crispy on the outside. Crunchy is right out, and mushy or soft, right out. For a New York pizza, you want it crispy, like think about an eggshell shattering on the outside, and then a fluffy, light, delicate interior. We call the outside the crust, the inside is the crumb, and the combined outside of the pizza is called a cornicione. All right, so we go for crispy and light. We want the flavor to be of properly fermented wheat, balanced with salt, not yeasty, but just a nice, mellow, nice, almost nutty flavor with it. The dough should be easy to stretch and top. That means we have to balance elasticity with extensibility. Elasticity is a dough's tendency to want to snap back. So if it has a really strong gluten network, it's going to snap back. If it's really elastic, it's going to open up. If it opens up too much, the dough will be too weak to hold the toppings and to fulfill its purpose. And if it's too elastic, it will you won't be able to open up and make a pizza with it. So you got to balance those two things. And then it should be easy to manage, which means the dough doesn't just blow up right after you pull it out of the refrigerator, but it also doesn't lie dormant for hours and hours, completely inactive and really not very good. So how do we get to these wonderful outcomes we're going for? Well, we have three levers. As Peter mentioned, he calls them the baking triangle. I call them the levers. They are the ingredients, time, and temperature. Let's get into those in more detail. First of all, let's talk about the flour in the pizza, okay? So our dough is made of flour, water, yeast, and salt. That's it. Every so often you'll have a variation on that with some oil or some malt, but by and large, it's just those four main ingredients. The flour is the heart of the pizza dough. And the flour is stronger with more protein and also harder to work with because it requires a longer fermentation. So let's talk more about that. Oh, no, here it is. Okay, great. So flour, higher protein, we're looking for like a 14 to 15.5% protein flour. Neapolitan flour is going to be 11.5 to 12.5%. And you got like your cake flour or whatever else, like baker's, like all-purpose flour will be in that 10% range. So 15.5 is a very high percentage protein. You notice I didn't mention a specific brand of flour because Righteous Slice has tried lots and lots of different flour brands, different blends, but in general we're looking for a very high protein, good, strong, high quality, respectfully milled flour. All right. Next, talk about water. Water actually increases the puffiness of the crust because the water in the dough will turn to steam when it hits the oven. It also increases the crispiness of the crust because a steamed dough actually for some reason in the oven will turn crispy on the outside, which both of those are amazing. And so we want as much water as we can get in that dough and still have the dough have the strength that we want. And also the water, if we don't bake all of it out during the baking process, that steam softens the dough again after a few minutes. So if we want it to stay crispy, travel well, and be that perfect balance of strong and light, then we need to have the right amount of water. Now, let's see here. Oh, Water also makes yeast more active. So more water, the dough will be more active. Less water, less active. And lastly, we'll talk about baker's percentages. So all dough is made of, bakers use baker's percentages. They'll basically take the flour, the amount of flour in the recipe, and they will say, okay, we're going to have 100 grams of flour. If the dough is going to be 65% hydrated, it'll have 65 grams of water in it. Now, 100 plus 65 is 165, right? So it seems a little bit weird. So when you hear 65% hydrated, it doesn't mean that, you know, there's more water than anything else. We take the flour weight and multiply it by the water, or the percentage, to get the amount of water. So if we had 100 grams of flour, 65% hydrated dough would be 65 grams of water. All right. Let's go on and talk about salt. Salt is an amazing ingredient. It not only adds flavor to the dough, but it also slows down it. It serves to control the yeast reaction so that the dough doesn't blow up as fast. It also gives strength to the gluten network, so you get a stronger final dough. Now, that's important because if you forget the salt, the dough is going to be more active, less flavorful, and easier to stretch. So if you see a dough that's really active, it's getting really big really fast, and also super easy to stretch, give it a taste, because if it doesn't have flour, you shouldn't be using that dough. You got to go find something else, or just basically not serve that dough for that day. All right. And then lastly, yeast. Yeast is amazing because it's a living organism. When added to flour and water, the yeast becomes alive and active inside the dough. It's literally alive. And the yeast reacts by eating or consuming the starches, the sugars, and the proteins in the flour. It produces gas and alcohol. So the gas are the bubbles, as you see in the dough, and the alcohol is the flavor or smell that you get from a properly fermented dough. So more yeast means more active, less yeast means less active. And most pizza recipes and most pizzerias will use between 0.5 and 1% yeast. But we're using somewhere between, sometimes as low as 0.1% yeast, sometimes as high as 0.25% yeast, but always a very small amount of yeast because we want to control that reaction. We want to have a longer fermentation, better flavor, and more easily digestible product. So that's why we vary the yeast. Now, yeast is also highly temperature sensitive. So if you move the temperature down to 40 degrees, the yeast becomes almost dormant. So you'll get more alcohol and more flavor development at a lower temperature. When you ferment at a higher temperature, like say 75 or 80 degrees, you get a lot of gas production, but not a lot of flavor. So we at Righteous Slice will do an early ferment at room temperature to get the gas going. Then we're going to cool it off, slow it down, add that flavor for a day or two, and then bring it out of the fridge, warm it up, and finally bake it. So the yeast is really important, and it's very temperature sensitive. So you've got to manage that temperature to keep the dough under control. All right. Lastly, let's talk about time and temperature. So we're going for a final dough temperature when we mix the dough so that we get the ideal amount of activity in that yeast. And I'm going to show you in a minute how to do that. All right. Then we do a room temperature bulk fermentation. That means we have a whole mass of dough. We let it rest at room temperature for a few hours. We're looking for the dough to become more active. So we're looking for a slight amount of growth in the dough before we cut it, ball it, and put it in the fridge. At which time we'll leave it in the fridge for a few days so that that yeast fermentation can, the activity in these can slow down and the flavor development can happen over time. Then lastly, we bring it out of the fridge and proof it at room temperature for at least an hour, but sometimes 2 or 3 hours to get it to warm up, to get it ready to bake, to get it easier to stretch. And then finally we bake it, where we transform it in the way that Peter talked about, where we get the caramelization, gelatinization, and coagulation of the proteins, starches, and that outer crust, all forming a perfect, light, delicate, creamy, soft, but crispy pizza. All right, so now let's talk about how to make the dough. So the first thing I want you to know is mise en place, which means we get all the ingredients out, we weigh them, and we have them all before our eyes so that we don't forget something, all right, in the right ratios, the right right amounts, and everything out. Let's talk about the desired dough temperature. That's pretty cool. We're going for a final dough temperature of 75 degrees, but if we had 73 to 78, we'll be okay. All you have to do is measure the air temperature with the thermometer, which means basically turn a room temperature thermometer on, write down that temperature. In this example, I put 77 degrees. Then you stick that probe into the flour bag, and you're going to read that temperature. It's usually a little cooler than the air temperature. In this example, it's 73 degrees. There's a friction factor on the mixer. That'll be given to you. In this example, it's 15. And when you add those three up, you get 165. Now you take that total and you subtract it from 225. So in this case, 225 minus 165 is 60 degrees. So we're looking for, in this example, a 60-degree water temperature. If the water coming out of the faucet is lower than 60 degrees, you'll want to warm it up till it's 60 degrees. If the water is higher than 60 degrees, you'll add a little bit of ice until you get that 60-degree temperature. This is important because when that dough comes out of the mixer, you want it to be that exact temperature that creates the activity, flavor, and texture that we're looking for. You can't get that if the dough is too cold or too warm. It's either going to take off on you or it's just going to sit there kind of lifeless. All right, now let's talk about the basic dough formula. This is a formula, not a recipe, because a recipe includes the steps that you follow to make it happen. And you'll get more of that in your hands-on training. Here we've got basically 100% flour, which is 90% a high-protein flour and 10% of a light whole wheat flour that gives it that nuttiness, a little bit of crispiness, and a little bit more extensibility, a little less chewiness. So that equals our 100%. Now, that makes these two weights together. This is one bag of high-protein flour, and this is 10% of that weight to get 24.948 kilograms. 63% water gives us 16.216 kilograms. 0.2% yeast gives us 50 grams, and 2.75% salt gives us 686 grams. We're going to go ahead and weigh these out and then combine them in the mixer according to the steps that are trained to you. The first thing you do is you get all the ingredients out. Then you add the water at the right temperature. You add the yeast and let it dissolve. Add the whole wheat flour and use a whisk to dissolve that. After you've got that whole wheat fully hydrated, go ahead and add the rest of the flour into the mix. Turn the mixer on, and then you're going to mix until it's fully incorporated and then let it stop. And rest the dough for about a half an hour. This is called an autolyse, and it allows the flour to absorb the water, the gluten to begin to form, and the enzymes in the flour to begin to activate, all naturally without any heat added, so that you're not over-activating or over-stimulating or overworking your dough. After that 30-minute autolyse, you're going to turn the mixer back on, and then as it mixes, add some salt, and that salt will basically be the final step. Once the dough is fully mixed, you let it rest for about 30 minutes, 30 to 60 minutes. Give it a stretch and fold as needed. You'll be taught that once again in the hands-on part of the training. And then after the dough has begun to be active, you're talking about 20 to 40% of growth in its natural volume. You go ahead and cut it, ball it, and then put it in the fridge for the fermentation. So that's the introduction to dough and dough making. I hope this gets you ready for your hands-on, and I can't wait to see the results you produce.